Now that we've put our interface definition together, we're going to start to create these other classes like characters collection and the linked list. Remember, the characters collection is going to represent a string. So inside that class, we're going to have like some data property or something like that that's going to reference the string that we are trying to sort. Also inside of characters collection, we're going to implement the swap, compare, and length methods that are customized for a string. Because we are implementing those methods, they will be compatible with the sorter interface, or the sortable interface to be clear, and so we will be able to pass them as an argument to our sorter class. So let's get to it. Back inside my editor, I'm going to find my src directory, and I'll make a new file inside there called characterscollection.ts. Then at the very top, we will immediately export a new class called characters collection. And then inside of here, we're going to do something very similar to what we just saw inside of numbers collection. So we're going to get some data property. We're going to define those three different, or I guess the one getter, and then two functions. And that's it. We'll then be able to automatically sort a string. So I'm going to flip back over. I'm going to set up my constructor. The constructor is going to have a public modifier on data, and that's going to be a string like so. So then we'll start to put together, how about the length getter to start? So I'm going to add a get modifier on here of length. Anytime we call this getter or reference the getter, we're going to try to return a number, and that's going to be the number of characters inside of our string. So we will return this.data.length. Then after that, we can start to compare two characters next to each other, just as we did with our numbers. So I'll say our compare function is going to have a return type of not void, but Boolean. And we're going to compare a left index that is a number against a right index that is also a number. And so now we get to put together the string implementation of comparing two characters next to each other. Remember, the entire point of customizing this for a string is that when we compare two strings, behind the scenes, it uses the character code of those strings. So remember, we went through that example a good number of videos ago. Where was it? Where we had the different, here we go, right here. So remember we had said, yeah, if we were sorting a string that has like capital X inside of it, we would expect the capital X to go all the way to the end, and essentially to follow kind of ascending value or alphabetical order. But a capital X actually gets reflected as failing a comparison against a lowercase a. And so even after we tried to sort this string right here, the capital X would stay on the left-hand side. So to deal with this, to make sure that we are comparing characters against each other fairly, we're going to first lowercase all these characters before we try to compare them. So we're going to essentially be comparing a lowercase x against a lowercase a, and so on. So to do so, back over here, we'll say return this.data at left index, and then we'll call to lowercase on it. Remember, this.data at left index is going to return a character or a single string. So we'll call to lowercase on it and get the lowercase version of that letter. So if it is capital X, we'll turn it into lowercase x and then do the comparison. So we want to know if the character on the left-hand side is greater than the character on the right-hand side, also in lowercase format. So on the right-hand side, it will be this.data at right index dot to lowercase as well. Now I'm going to save this file, and when I do so, it's probably going to jump because this is a really long line, and so it's probably going to be reformatted. Yeah, there we go. So I'll zoom out for just a second so you can see that entire line. All right, so we've now got a correct definition inside of here for the compare function. So now the last function we have to put together, as defined by our sortable interface, is swap. So let's put that together now as well. So I'll define my swap method. Again, I'll get a left index that is a number, a right index that is a number, and this one is not going to return anything, so we'll put on the void annotation. All right, so now inside of here, we need to swap two characters inside of a string. Remember, we cannot swap characters directly inside of a string, so we need to figure out some kind of workaround here. A very easy workaround would be to just take the string, separate it into an array of characters, and then do the swapping in the same fashion that we did back inside of numbers array over here. So that's going to be a really easy way to do this. We could technically do this by using the slice method that strings have as well, but that is like pretty darn complicated, a little bit overkill here, so we'll just do it a little bit more straightforward. Okay, so we're going to first separate the string into an array of characters. So we'll call this something like, how about, nah, not string array. How about characters? That makes sense. Yeah, I like that. Okay, so we'll call it characters. We'll do this.data split on empty string like so. So now if we mouse over characters, it's going to be an array of strings. And when we say array of strings, it's really going to be each of these one separate character. So now we're going to look inside that array and try to swap the two characters at left index and right index. Like I said, just as we did before. So I'll say const left hand. This is going to be the left-hand character in each pair that we want to swap. And we'll take this from, not this, but characters at left index. Then at characters at left index, we're going to throw the right-hand side over to the left. And then restore the left-hand side onto the right hand. So characters at right index is going to be left hand, like so. So now the characters array has had everything swapped out. Now the last thing we have to do is make sure that we update this.data with this new string. So to do so, down here we'll say something like this.data is going to be characters. Remember, characters is an array of strings. Each one is one single character long. And we're going to join that back together on empty string like so. And that's pretty much it. Okay, so right here in this video alone, we have implemented the ability to sort strings. And the super important thing here to realize is that we don't have to know anything about the actual sorting algorithm. The only thing we had to do was compare two characters and then swap two characters, and then technically also return a length. But I think you can agree with me that at the end of the day, if you were asked by some engineer or someone else on a project, if you were asked, hey, could you write a sorting algorithm really quickly? At the end of the day, I think a lot of engineers out there would probably look up some documentation on different sorting algorithms or something like that, and maybe just get a quick reminder on how to do one or how to write one out. Well, maybe not for bubble sort, but again, at the end of the day, you might need a quick reminder on how to implement a sorting algorithm. But if some other engineer told you, hey, add in support to some new class for our sorting algorithm, and for that, if all you had to do was implement compare and swap, I think the average engineer could define these two functions right here without a lot of trouble at all. I don't think that you would really need to look up any documentation to figure out how to put these functions together. And by just defining these functions, you have added in support for sorting this data structure, this string right here. So this is the power of interfaces in action. We have some very generic code inside of sorter.ts. In order for it to work correctly, it has to work with some other object that implements those functions. So rather than having to memorize these for loops right here, where it'd be really easy to make a typo, all we have to do, add those functions. That's it. We are good to go. We can now sort just about anything you can possibly imagine. Okay, so now the last thing we need to do here is a quick test. So back inside of index.ts at the top, I will import characters collection from characters collection. I'm going to comment out all the sorting stuff that we just did right there around numbers collection, just to keep this file a little bit clean. So then we'll create a characters collection, which is really just kind of representing a string. And remember, the argument to it is going to be the string of characters we want to sort. So I'll do like capital X, A, lowercase y, B, something like that. We can then create our sorter and pass in the characters collection. When we do that, we do not see an error because characters collection correctly implements the sortable interface. If we went back over to characters collection and we say change the name of one of these variables or one of these functions inside of here, so maybe instead of compare we said compare characters. If we did that, our class no longer correctly implements that interface because it has the incorrect function name. And so now if we went back over to index.ts, we'd very quickly see an error message. And it tells us, hey, you did not put in that compare function. So I'm going to redo this, change it back to simply compare, save this again, and now the error message goes away. Okay, so now with our sorter class, we can call sort, and we'll do a console log of the actual string that is on our characters collection. So I'll say console log characters collection.data, and we'll just make sure that that thing got properly sorted. So I'll save this file, go back over to my terminal, and I see my sorted string. AAB capital X, notice that capital X got put in the correct location, and then the Y. Awesome. Okay, so that's pretty much it. Like I said, I can't repeat this enough. This is extremely significant because we don't have to memorize the actual sorting algorithm anymore. We only have to memorize, okay, define compare, define swap, get the length. That's it. We now have support for sorting just about any type of arbitrary collection of data out there. So let's take a pause right here. When we come back in the next section, we're going to start to implement our last data structure, the linked list. So I'll see you in just a minute.